This is a basic photoelectric effect scenario, which of course is all about the conservation of energy. So we're going to find the energies that we can, and then we're going to look for the work function from the material, and then the stopping potential required to actually stop the electron from leaving the metal in the first place. So first, I'm going to start with my photon energy that's coming in. I've got the wavelength up here, so to calculate the energy of that photon, I can use Planck's hypothesis, and the energy would be equal to hc over lambda. So if I put in Planck's constant, speed of light, and then divide by the wavelength, I have got an incoming energy of 1.33 times 10 to the negative 18 joules. So that's how much energy is coming into the scenario. Now I can also find the kinetic energy of the electron since I have its speed. So if I find the kinetic energy of my electron using basic 1/2 mv squared, I can find out that the kinetic energy is about 8.0 times 10 to the negative 20 joules. So I've got more energy coming in than the electron has, which of course means that some of it's being left behind, which of course is the work function. So the amount of the work function, the value of its amount of energy would be the difference between the two. So that would be the energy that was incoming from the first photon, or the initial energy, take away the kinetic energy. So if I just subtract those two energies, I have about 1.25 times 10 to the negative 18 joules was left in the material as the work function. And usually work functions are given in electron volts, so I can convert this to electron volts, and that would be about 7.8 electron volts. Now I can try and find the stopping potential for the electron. Now, of course, the stopping potential is all about taking away the energy of the electron, sort of canceling it off with an electric field. So I need to cancel off its kinetic energy. I want to cancel off its kinetic energy by doing work with an electric field. And of course, the basic way to calculate work for an electric field is just QV. So the amount of kinetic energy the electron leaves with must be equal to QV. So if I take that, 8.0 times 10 to the negative 20 joules, and make that equal to QV, I just have to divide the amount of kinetic energy by the charge of the electron. And if I do that, I can find out that the stopping potential required is about half of a volt. So about 0.5 volts between two plates would stop the electron from leaving.